All right, write up those rules and then we'll look at solving some questions. All right. Now, these are just going to be integration by recognition because based on the rule, we know that just to be clear, this A right here is the derivative of the power. This A right here is the derivative of the denominator. And this A right here is the derivative of the bracket. All right. So that is how we get those different A's. And we could even add another one to it, like say if we have the integral of 1 over x dx, it is just equal to ln x plus c. All right. So that's simple, but that's still coming from this rule right here. All right. So we're asked to find the integral of this function. So if we should differentiate the denominator here, we're just going to be left with 3. So it's going to be 1 over 3 ln of the denominator. Go ahead, Mr. Griffiths.
So record.
Yeah, man.
Oh, 2 minutes. I see. So this record. Oh, yeah. All right.
Mhm. Man, we have to accommodate those who are not coming, provided that they do watch the recordings. They can benefit from it. All right, let us continue. Now, the reason why I'm doing it like this is because I want to show you the difference between the two, right? When to do what, when to do, when you're not supposed to do it. Now, because this has a power, you have to take this into consideration. Bear in mind, there's a rule in indices that says if you have a to the negative n, it's equal to 1 over a to the n. So this right now is written in the form of 1 over a to the n. So to solve this, we have to now get it in the form. We are going to get it in the index form, which is going to be the integral of, if all of this is a, it's going to be 2x plus 5 raised to the negative 3 dx. All right. And then you integrate, which is to add 1 to the power, divide by the new power. And we know that when we integrate it in this form, ax plus b to the n is going to be equal to ax plus b to the n plus 1 divided by a times n plus 1. So add 1 to the power, 2x plus 5, add 1, negative 2, and we're going to divide by negative 2 times 2. If you should differentiate the bracket, so this a right here is the derivative of the bracket. So if we differentiate this bracket, we get 2, and then the new power is negative 2 plus c. We have to add the plus c because it's a indefinite integral. So this is just simply 2x plus 5 raised to the negative 2 divided by negative 4 plus c. Plus c. Now, based on the rule that we looked at earlier, this is again an exponential function. So if we're integrating, right, what we're going to have is going to be so it's going to be 1 over the derivative of the power, which is going to be 4 times e to the 4x plus 5 plus c. So notice this is the rule that applies right here. All right. So it's just 1 over a times but the same function plus c, which is the constant of integration. Try this one, please. All right, let's see if we have the same thing. It's going to be 1 over negative 3 e to the 4x minus, sorry, e to the 4 minus 3x plus c. Did we get that answer? Not hearing from anybody.
Delete answer.
Go again.
Mine did wrong, sir.
I'm not sure why I'm not hearing you clearly. Could you just repeat?
I'm saying I got it wrong, sir.
Oh, all right. So do you need any clarity on it to understand it? Okay. In a case like this, what we could do here is factor out 2. Let's understand why. Notice, if we say 2 times 1, we're going to get 2. So if we factor out the 2, we're going to have 1 remaining. Why is that important? Because we can write it as 2 times the integral of 1 over 2x minus 3 dx, because we factor out the 2. Because if you multiply the 2 times the 1, you still get back the 2. Now it is in the form where we can write it as 2 times, when we integrate it in this form, 1 over ax plus b, we're going to get 1 over the derivative of the denominator, which is going to be 2, ln of the denominator plus c. But when we multiply by 2, 2 times a half is just 1. 1 ln is just ln of 2x minus 3 plus c. So that is what we would end up with for our answer. Let me know if there is any part of it I need to clarify. All right, let's continue. Now, the integral of cos is just sine, right? So when you integrate cos, you get sine. So we're going to get 1 over 3 sine 3x minus 1 plus c. Because remember, this is it applies to this rule right here. Right? So you're going to get 1 over the derivative of the bracket. Yeah? What happens if we have integral of sine 2x? Try that one for me, please. So we're going to have a half, well, negative, because when you integrate sign, you get negative cos. Cos 2x plus c. Did we get that answer?
Yes, sir. Me get down there.
Okay.
Oh, yes, sir. Taji, have up in my hand.
Hmm.
I really love the church. 10 o'clock.
All right, so when you hear of a substitute, it means that you're going to use something in the place of, or use something to replace something else. So we're talking about U substitution, but bear in mind this function is being integrated with respect to x. So because you're integrating with respect to x, the function is written in terms of x. But if we're going to change the function to u, so that means we're now going to be integrating with respect to u. If you're integrating with respect to u, that now means you have to change the derivative, change with respect to x with respect to u, because you have changed with which, with what variable you're integrating the function. What do I mean by that? Let's look at it so I can point it out to you. We're going to let u equal to what is in the bracket, which is 2x plus 3, which therefore means that if u is equal to 2x plus 3, if I take the derivative of u with respect to x, it's going to be equal to 2, right? You're going to see why is it that we're differentiating u with respect to x. Now, this is one fraction. 2 can be made into a fraction by writing 2 over 1. And then we can cross multiply. So 1 times du is equal to du, 2 times dx is equal to 3 dx. But what I'm solving for is dx. Why am I solving for dx? It's because I need to find a replacement for dx in terms of u. Divide by 2, divide by 2. That means du over 2 is going to be equal to dx. Let's look at why this is necessary. We said that 2x plus 3 is equal to u. So I'm going to take the integral of u. So all of this is now u raised to the 4th power. I cannot write dx. That means I'm integrating, and this is 2 different variables. The variable is u, but I'm integrating with respect to x. That cannot be the case. So what is dx? Dx is du over 2. So instead of writing dx, we're now going to write du over 2 because we're integrating with respect to u. So the replacement for dx is du over 2. So it is going to be the integral of u to the 4th power du over 2. All right. So in this step, we're going to factor out a half. Why are we factoring out a half? Do you recognize that this 2 is in the denominator? So because the 2 is in the denominator, dividing by 2 is the same thing as multiplying by a half. Notice if we have 6 divided by 2, that's going to give us 3. And if we have a half times 6, it's going to give us 3. So dividing by 2 is the same thing as multiplying by a half. So here we say that we're going to factor out a half because it is the same thing as saying that you're dividing by 2. So we're going to factor out a half. So we're going to get half times the integral of u to the 4th power with respect to u. How do we integrate? Add 1 to the power, divide by the new power. So it is going to be half times the integral of u to the 5th power divided by 5 plus c. 1 times u to the 5th, u to the 5th, 2 times 5 is 10 plus c. What is u? 2x plus 3 raised to the 5th power divided by 10 plus c, and this is your final answer. Let me know if there is any part of it I need to clarify. All right, seems like we're good. So we'll just continue when you're finished writing. All right, let's look at another one. Let's go to the next page. So we are integrating x cos x squared dx. So what is in the bracket? So once you see a bracket, anything under a root, well, I'll write down what you must notice every time you're going to try and make something u. Some questions will tell you what to use as u, while some you have to find it. So I'm going to write down some things that you must pay attention to when you're going to select your u substitute. So u is going to be equal to x squared. So if we differentiate u with respect to x, we're going to get 2x. All right. So watch this now. We need to find out what is going to be dx. 1 times du, 2x dx. Solving for dx, divide by 2x, divide by 2x. So dx is going to be equal to du over 2x. All right. So look at this now. We're going to have the integral of x cos u du over 2x, because anywhere we see dx, we're going to put that. All right. Now I want you to note something. You have an x in the numerator and an x in the denominator, so they will cancel with each other. All right. So you have the integral now of cos u du over 2. So you're going to factor out a half. Half times the integral of cos u du. The integral of cos is just going to give us sine. So we're going to get a half sine u plus c. But what is u again? So we're going to get a half the sine of x squared plus c. So that's what we would end up with for our answer. Look at it carefully and see if there's anything you need me to clarify. You can let me know. And I'm going to ask you to try this one. So whatever is in the power, that is what you're going to make be your u. So 5x is your u. Go ahead with this one. Well, let me just write it there. U is equal to 5x. So try that one for me, please. All right, so if you're, did we get the answer for this one?
Not exactly sure.
Okay. So we just have to bear in mind that that when we integrate e to the u, we get back e to the u. And then you are multiplying by 1 over the derivative of the power. We could have even written this as 1/5 e to the 5x plus c. So that's you could have done that and it wouldn't have been a problem. All right. Give number 4 a try as well. All right, so what we're going to do, we're going to say let u equal to the denominator. So the derivative of u with respect to x is going to be equal to 2. We have another 2 again, so we know it's going to be du over 2. That's dx. So the integral of 1 over u, du over 2, we're going to factor out 2. Sorry, factor out a half. So we're going to get half times the integral of 1 over u du. And rule number 6 says if we integrate 1 over u, we just get ln of u plus c, but we know what u is. So it's going to be half times the ln of 2x plus 7 plus c. Try this one for me. U is going to be what is in the bracket, which is going to be 4x. So try this one, please. Derivative of u with respect to x, 4. That means dx is going to be du over 4. Integral of the sine of u, du over 4. Factor out a quarter because the 4 is in the denominator. So you're not factoring out 4, you're factoring out a quarter. There's going to be a quarter times the integral of the sine of u du. When you integrate sine, you get negative cos. So it's going to be negative a quarter cos of u plus c. But we know what is u. U is equal to 4x. we're going to let u equal to x to the fourth plus 5. The derivative of u with respect to x is going to be equal to 4x cubed. So that means dx is going to be equal to du over 4x cubed. So we're going to have the integral of x cubed e to the u du over 4x cubed. This x cube is in the numerator, this x cube is in the denominator, so we can cancel. So what we're going to end up with is the integral of e to the u du over 4. I'm going to factor out a quarter. So we get a quarter the integral of e to the u du. Integrate e to the u, we're just going to get a quarter e to the u plus c, which we know is just going to be a quarter e to the x to the fourth plus 5 plus c. Look at it, let me know if there is any part of it I need to clarify before we have to continue.
Sorry, you hear me?
Go ahead.
I say, I mean, I want to say, earlier, the one we did earlier, the sine and cosine one, may get the right answer, but me never did use the with respect to you, and use the rule with the give when you just start with
Yeah, man.
the first rule. So if there's a question like that, me can just use the rule there to solve it.
Yeah, man.
Oh,
So
okay, sir. Yeah.
there are just different ways it can be done. Some of the integrations only can be done using u substitution, and some of them it can be using different methods. All right.
All right, sir.
Yeah, because how they are going to write the questions, the only way you can integrate it. Well, at this level, based on what we're doing. All right, based on the course outline.
All right, yes, sir.
So in a case like this, what is under the square root, we have to use that as our u. All right, so u is equal to cos x plus 1, derivative of u with respect to x. Differentiate cos, we're going to get negative sine x. All right, so that's when you differentiate cos. So that means du over negative sine x is equal to dx. So we're going to have the integral of sine of x, the root of u, du over negative sine x. So I want to bring back your attention to one of the rules of indices. It says that if you have the root of a is equal to a to the half, right? So keep that in mind. This will cancel with this. One is in the numerator, one is in the denominator. So we're going to factor out -1 because you have the negative in the denominator. So you're going to factor out -1. Because the negative not canceling, you would have to be dividing, reducing it with another negative for it to cancel. So you're going to get the integral of u to the half -1 u to the half du. All right. So the root of u is going to be u to the half. Right? And the signs cancel, you factor out the -1. When you integrate u to the half, add 1 to the power, divide by the new power. So it's going to be -1, add 1 to the power, u to the 3/2, divide by 3/2, plus c. What is u? -1 times u gives you negative u, so it's going to be the negative of u, which is going to be cos x plus 1 to the 3/2, divided by 3/2, plus c. All right, so we're going to look at these using some definite integrals now. So that means we're not using the plus c. Taking the integral from 0 to 1 of 2x plus 3 squared. Now, this right here, so, is the limit for x. This is a limit for x. All right, so bear this in mind. This is the lower limit for x. This is the upper limit for x. Why we're pointing that out, that is going to become important very soon. We're going to let u equals to 2x plus 3. So the derivative of u with respect to x is going to be equal to 2, another 2 again. So we know that dx is going to be equal to du over 2. So now look at this. I'm going to integrate, and this is now going to be u squared du over 2. I cannot write 0 and 1 right here, so because those were the limits for x when you're integrating with respect to x. So I now need the limits for u. So we need to find the limits for u. But here is it we know. We know that x is equal to 0 and we know that x is equal to 1. So when x is equal to 0, u is going to be equal to 2 times 0 plus 3. So u is equal to 3. And when x is equal to 1, u is going to be equal to 2 times 1 plus 3. So u is equal to 5. These are now your limits for u. So we're going from 3 to 5 because u is equal to 3, u is equal to 5. Factor out a half. Right? So we're going to get half times the integral from 3 to u of u squared du. Integrate, add 1 to the power divided by the new power. So it's half times u cube divided by 3. And it is from 3 to 5. You can go ahead and work it out as is, and then you multiply by a half, or you can multiply by a half from here. Either way, you will still end up with the same answer. So it is going to be when u is 5 and when u is 3. So it's going to be 5 cubed divided by 3 minus 3 cubed divided by 3. So we work this out, and whatever our final answer is, we multiply by a half. So it's going to be 125 minus 27. So it's going to be half times 98 over 3. So our final answer is going to be 49 over 3. So that's the final answer for this integral right here, using the u substitution. Let me know if there is any part of it I need to clarify. All right, so we're going to get u is equal to x squared. Derivative of u with respect to x is equal to 2x. So du over 2x is equal to dx. So what we're going to get now is the integral of 2x e to the u du over 2x. So we need to find the limits for u. So when x is equal to 0, u is going to be equal to 0 squared. So that means u is equal to 0. When x is equal to 1, u is going to be equal to 1 squared. So u is equal to 1. So it doesn't change for this one. So it's going to be 0 to 1. This 2x will cancel with those 2x. So we're going to get the integral from 0 to 1 of e to the u du. Integrate e to the u, we just get back e to the u. And it is from 0 to 1. So this is when u is 1 minus when u is 0. So we're just going to get for the final answer e minus 1. Anything raised to the power of 0 is equal to 1. And anything raised to the power of 1 equal to itself. So we'll just get e minus 1. All right, so if we can do the number 10, I try, please. u is equal to 4. All right, so we're going to have the integral from 1 to 4, 3x times u to the 4th power du over 6x. This reduced into itself goes 1 time, this into this goes 2 times. So we're going to factor out a half. So we're going to get half times the integral from 1 to 4 of u to the 4th power du. Integrating, add 1 to the power, divide by the new power. So it's going to be half u to the 5th, divide by 5, 1 to 4. So we can just work it out as is. So we're going to get 4 to the 5th power over 5 minus 1 to the 5th power over 5. And then whatever we get, we multiply by a half. So we're going to end up with a half times 1023 over 5. So this is going to give us divide by 10. You either leave it as a fraction or as a decimal, it is 102.3. Right? So you can choose to leave it as a fraction. All right, we're going to try one more like this, and then we'll look at something else. So u is equal to 3x plus 1. So the derivative of u with respect to x is going to be equal to 3. So dx is going to be du over 3. When x is equal to 0, u is equal to 3 times 0 plus 1. So u is equal to 1. When x is equal to 1, u is equal to 3 times 1 plus 1. So u is equal to 4. From here, we're going to factor out 3 because the 3 is in the numerator. So we're going to factor it out. So we're going to have 3 times the integral from 1 to 4, 1 over u, du over 3. All right. So we'll get du over 3. Now this 3 is multiplying and this 3 is dividing, so they will cancel with each other because one is doing a division operation, one is doing a multiplying, so they will cancel out with each other. So we're going to have equal to the integral of 1 over u is just going to be ln u from 1 to 4, which is going to be the ln of u, which is 4, minus the ln of 1. So this is just going to be ln 4 minus the ln of 1 is 0. So you're just going to end up with ln 4 for your answer. Because the ln of 1, that's going to give you 0. All right, you can go ahead with any questions you have at this time. If not, we're going to look at something else shortly. All right, so we're going to be looking at how to find the area between a curve and the x-axis or the y-axis. And we're going to see if we can do a few questions as well that involves the volume. All right, so we want to find the area that is bounded by this region here. All right, so it is going to be that the area is equal to the integral of the function from 1 to 5. These are the limits of x because the region is from 1 to 5 on the x-axis where it is shaded of the function, which is 2x plus 3 dx. So we just go ahead and integrate as is, add 1 to the power, divide by the new power. The integral of a constant is the constant times the variable. And as you know, we're integrating from 1 to 5. These two cancel. So we'll get x squared plus 3x. And this is from 1 to 5. So it is when x is 1 and when x is 5. So we can just come up here with it. So it's going to be 5 squared plus 3 times 5 minus 1 squared plus 3 times 1. 25 plus 15, that's going to give us 40, minus 1 plus 3, that's going to give us 4. So that means the area is equal to 36 units squared. So that's the area that is covered by this region right here that is shaded. All right, so for this one, we have to use the rule of indices. That says if you have a to the negative n, it's equal to 1 over a to the n. So that means if we have 2 over x squared, it is going to be 2 times x to the negative 2. All right. So it's going to be the integral, the area is going to be equal to the integral, sorry, from 1 to 7, no, it's from 3 to 7 of 2x to the negative 2 dx, which is the same thing as 2 over x squared. Now, this is going to be integrate as is, so it's 2x to the negative 1 divided by negative 1, and we're going from 3 to 7. Anything divided by negative 1 is going to be a negative, so we're going to have negative 2x to the negative 1. 7 to 3. So you can use this on your calculator. Please note that x to the negative 1 is just 1 over x. So if you have negative 2 times x to the negative 1 is going to be equal to negative 2 over x, right? This is the same thing. So this is the same as saying negative 2 over x from 7 to 3. So this is going to be equal to negative 2 over 7 minus negative 2 over 3. So it's going to be negative 2 over 7 plus 2 over 3. All right. Which is going to give you a final answer of 8 over 21. So that's going to be the area. So the area is equal to the integral from 1 to 2, multiply, we get 3x minus x squared dx, integrate as is, 3x squared divided by 2 minus x cubed divided by 3, and we're integrating from 1 to 2. So this is going to be 3 times 2 squared over 2 minus 2 cubed over 3. And then we're going to minus when it is 1. 3 times 1 squared over 2 minus 1 cubed over 3. So this right here, 2 squared is 4, 3 times 4 is 12 divided by 2. We're going to get 6 minus 8 over 3 minus, this is going to give us 3 over 2 minus 1/3. So you have 6 minus 8 over 3. So we get 10 over 3 minus seven over 6. So our final answer is going to be 13 over 6 units squared. All right, so that was with the x-axis. We're going to look at what happens if we're integrating with respect to the y-axis. So if you're integrating with respect to the y-axis, say for instance, you have a function, and this is a, that's b, y is equal to f of x, and you want to find the shaded region here, then the area is going to be equal to the integral from a to b of x dy. All right, so that's how we're going to integrate these functions. Let's go. So how this graph is that it's going to look like that. So 0, y, x. So it's come all the way down to -1. So all of this and all the way up to 8. So we want all of this part as well. So it's two sides to the graph, right? So you have the bottom part and you have the top part. So please note we have the function y is equal to x cubed, all right? And we are looking to integrate this function. But because this function is in terms of x, so y is written in terms of x. So what we have to do, step 1, make y the subject. So you have to solve for y. So we need to get x by its, sorry, make x the subject, x, because y is already the subject. So we need to get x by itself. So we need to take the cube root of both sides. So the cube root will cancel with the cube, so you're going to get x is equal to the cube root of y. Another way of writing this is y to the 1/3. So the area is going to be equal to the integral from -1. Well, we're going to have to do it two ways. All right, so from -1 up to 8 of y to the 1/3 dy. But since it goes down into the negative, you have to do the calculation in two parts in order to get the answer. We're going to do the calculation for the top portion and then for the bottom portion as well. So it's going to be the integral from 0 to 8, which is the top part right here, of y to the 1/3 dy, plus the integral from -1 to 0 of y to the 1/3 dy. All right. So the bottom part is from -1 up to 0, and then the top part is from 0 up to 8. All right. So from -1 up to 0 gives you the area of the bottom part, and then 0 up to 8 gives you the area of the top part. So integral, so we integrate as is, add 1 to the power divided by the new power. So we're going to get y to the 4/3 divided by 4/3. And we're going from 0 to 8 plus y to the 4/3 divided by 4/3. And we're going from -1 to 0. So all we have to do is just substitute in y, and you have to use the calculator for this. All right, so it is 8 to the 4/3 over 4/3 minus 0 to the 4/3 over 4/3 minus, well, plus, sorry, all of this part, which is 0 to the 4/3 over 4/3 minus -1 to the 4/3 all divided by 4/3. So this is the area of the top part, area of the bottom part. Once you add them together, you'll get the total area. So this is going to be 2 cubes. So this is 16. So 16 divided by 4/3. So that's 12 minus 0. So this is going to be 12. All of this side is 12 plus this is 0, and this is going to be positive 1. 1 divided by 4/3. This is going to be 3/4. So it's going to be 12 3/4 units squared. So that's going to be the area of both the top and the bottom part. All right. So and we do this because again, the area goes below, well, the parts of the curve go below the x-axis.
So you can ask a question.
Go again.
Another question, sir.
If you can ask a question.
Let's say, is this the last topic for module 2?
Yeah, man.
Okay. Wait, sir. So, wait, for module 2, sir?
Module 2, yeah.
So, what am I thinking? Module 3?
No, there's no module 3. It stops at module 2.
Okay, sir. So, this differentiation, integration, and limits are what I was supposed to get ready for the test.
No, just integration and differentiation.
Oh, okay, sir. Thank you.
Yeah. All right, so we want to find the area of this portion right here that is shaded. Notice that it starts all the way from 0 up to 4. So we're going to make x the subject. So we have y is equal to x squared. So we take the square root of both sides. So x is going to be equal to the square root of y, or y to the half. Yeah, y to the half is the same thing as x. We did when we did indices, we look at that. So all we need now to do is integrate. So the area is going to be equal to the integral from 0 to 4 of x. Sorry. See, I write back x instead of y. So I'm going to say, how may I write x here? So dy. Add 1 to the power, divide by the new power. So we're going to get y to the 3 over 2, divided by 3 over 2. And we're integrating from 0 to 4. So this means that it's when y is 4, so the 3 over 2, minus 0 to the 3 over 2, divided by 3 over 3. All of this side is 0 because 0 to any power is 0, right? So it's going to be equal to 0. So over this side, 4 raised to the 3 halves, that's going to give us 8 divided by 3 over 2. So all of this side is just going to work out to 16/3. And so that's what happens when you are working with um, a rotation, whether it be not a rotation, the area between a curve on the y-axis or a curve on the x-axis. What happens now is that we're going to look what happens if we have the area the volume form when a solid is rotated around a particular axis, whether the x-axis or the y-axis. All right, hold a second, please. This document finished, so I'm gonna get, because this is the last page in the document. So let me just bring up a new one, please. All right, say for instance, we have this function here, and it is rotated about the x-axis. All right, so the volume is going to be pi times the integral from 1 to 3 of the function, which is x squared plus 1, and you have to square the function with respect to x. All right. So it is going to be x squared plus 1, squared meaning that it is multiplying by itself. So x squared times x squared. X squared times x squared is going to give you x to the fourth. X squared times 1, x squared. 1 times x squared, x squared. 1 times 1 is 1. So it's going to be x to the fourth plus 2x squared plus 1. So it is going to be pi times the integral from 1 to 3, x to the fourth plus 2x squared plus 1 dx. So we're going to integrate. So we integrate as is, add 1 to the power, divide by the new power. So we're going to get x to the fifth over 5 plus 2 x cubed over 3. Integral of a constant, constant times x, and we're going from 1 to 3. So what we can do is just integrate it and then multiply by pi. Substituting the values, and then once we're finished, we just multiply by pi at the end. So we have this side minus when x is 1. 1 to the fifth over 5 plus 2 times 1 cubed over 3 plus 1. Once you get the final answer, you just multiply it by pi. What I'm going to do, in the interest of time, I'm just going to work this out in my calculator and then write the final answer. So the final answer is going to be 476 over 15 times pi units cubed. So when we work out all of this part and subtract all of this part from it, your final answer is going to be 476 over 15, and you're multiplying by pi units cubed. So you can just, once in the exam, you can just put it in your calculator and work it out. So you're not spending a lot of time, doing things that you don't have to spend time doing. All right.
Yes, sir.
All right, let's look what happens if the rotation is about the y-axis. We can even look at the same two questions that we used earlier. So y is equal to x cubed. But for this, we are only taking the top part. All right, so we're only taking from 0 up to 8. So we're going to first make x the subject. So we have y is equal to x cubed. Find the cube root of both sides. So as we did know, in the previous question, we know that it's going to be y to the 1/3, that's equal to x. All right. So the volume is going to be equal to pi times the integral from 0 to 8 of y to the 1/3 dy. All right. So it's pi. Oh, sorry. See, I did something there. Would get the question wrong. I didn't square the function. So it's a good thing I look quickly and recognize. Remember that we need to square whatever the function is, because you're not doing area. So it's going to be pi times the integral from 0 to 8. 1/3 times 2 is going to give us y to the 2/3 dy. So we're going to integrate, add 1 to the power, divide by the new power. So we add 1 to the power, so we're going to get y to the 5/3 divided by 5/3, and we're going from 0 to 8. All right. So the volume is going to be equal to pi times, when y is 8, when y is 0. So we're going to have 8 to the 5/3 divided by 5/3 minus 0 to the 5/3 divided by 5/3. And that is what we're going to get for our answer. So you can just go ahead now with your calculator and just work this out, and then you will get your final answer. So it's going to be 32. So all of this part is 0. So the volume is just going to be equal to 96/5 pi units cubed. So this is 0 to any power is still 0. And if you have 0 divided by a number, it's still 0. So only this part you're going to work out. 8 to the power of 5/3, and then you divide by 5/3. Yes. All right, so as I said, doing the two that we did with the area. So the next one is y is equal to x squared. Mhm. So, and it is rotated above the y-axis. So step 1, you're going to make x the subject. So we have y is equal to x squared. Find the square root of both sides. So we know that y to the half is equal to x. So the volume is equal to pi times the integral from 0 to 4 of y to the half, and you're going to square dy. Half times 2, that's going to give us 1. So we're just going to get the integral of y. The volume is going to be equal to pi times the integral from 0 to 4 of y dy. Integrate, add 1 to the power, divide by the new power. So it's pi times y squared over 3 from 0 to 4. So the volume is equal to pi times 4 squared divided by 2 minus 0 squared divided by 2. So 16 divided by 2 is going to give us 8. So the volume is going to be equal to 8 pi units cubed. All right. Now, pi here is equal to 22 over 7 or 3.14. So that is what pi is used as in these questions, because notice these don't have anything to do with angles. When you're using angles or trig, pi is 180, but once you're doing calculation dealing with measurement, pi is 22 over 7 or 3.14. All right, so that's the difference. All right, if you have any questions, you are free to ask. So bear in mind, so as I mentioned, some persons say we have had indications from persons that they haven't done the assignments in Moodle as yet. Moodle was closed last week. I didn't get any notification to say it was open back. So what I'm going to do, I'm going to post your assignments in the Teams as we would normally do and have you complete them there and submit. So the project, bear in mind, I did mention that the project, there is 4 persons to a group. I don't know how you guys are going to work that out, if you are just going to be working with just those persons who have been coming to class or what the situation is. But I'm going to post the assignment in the Teams and you just have them done and submit back to me by the deadline that is going to be indicated on the assessments. All right. Any questions?
No, sir.
All right. Thank you all for your time. Take care until we meet again.
Yes, sir.
Yeah, man.